even gauge interaction there are a lot of Nobel prizes, but this is a recent Nobel prize, right, in Higgs. So, Higgs is what we write Higgs particle, but there are many people who simultaneously propose this theory. So, the names are Brout, Englert. Englert got the Nobel prize along with Higgs, these two guys, Guralnik, Hagen, Keeble, Anderson. So, this is condensed matter physics, okay. And even Russians like this Polyakov and Migdal, supposedly they had the idea. Okay. So, let us look at what. So, this is the same Lagrangian which I wrote in the past, interaction term, and this is potential and this is free part. Okay. Now, symmetry breaking, we need to do symmetry breaking, what I said of Goldstone mode. Okay. First Goldstone mode. So, let us look for symmetry breaking. So, I make a change of variable psi as rho e to I theta. Okay. So, we done it in the past, right, magnitude and theta, plug it in. So, these parts are straightforward, mu squared, rho squared, and this is lambda rho 4, right, that is straightforward. Okay. So, here these operators become pretty nice. So, if I take the derivative, then I get del mu rho e to I theta, and this is as is, and del mu theta comes here. Okay. So, okay. So, we can rewrite this as a del mu rho. I have okay. So, we make a new change of variable. This part is called I q c mu. I make a new variable c mu. All right. So, this is same as here, and this thing is called, whole thing is called I q c mu. So, you take the q out. Okay. So, c mu is basically proportional to a mu plus component coming from theta, del mu theta. So, if I plug that in, so I will get something here which is a minus sign. So, if I do all of it, there is a cancellations. Okay. I did it myself, but I will not do the algebra here. So, after this transformation, this part, the left part is basically these two terms. Okay. So, one is coming from this guy, plus minus will cancel, this guy with that guy, and the square will give us, well, basically I have to use this c mu, and c mu will come. So, the c squared is c mu c mu. So, there is something interesting is staring at us. So, we got something right now which is proportional to c squared. Okay. So, that means the photon may get some mass. Okay. So, that is you can see something is peeping in here. Now, before going to that, let's do it this algebra properly. So, this is a free field, but by the way, this f mu nu I write in terms of c mu's. So, we write earlier f mu nu was defined as del mu a nu minus del nu a mu, but it turns out this this operator will cancel. So, we can, instead of a mu, you can write as c nu and this c nu. So, I use c mu. So, I use a new variable c. My c is a new potential, 4 potential you may call. Now, let us focus only on the rho part. So, I will right now I will ignore this and I ignore this. Let us think of only the matter field. Please remember psi is the matter field and F is the electric field, well, electromagnetic field, and the interaction is there is via this gauge interaction. Okay. So, I am just going to write in terms of differential equation. I feel much comfortable with differential equation. So, if I keep these 3 terms, I can write down the differential equation, right, del phi equal to del L del phi mu del mu. Okay. So, the derivatives parts will come here. We done this in the past. Okay. This is nothing but time derivative square minus grad square. and these two guys will give us rho and rho cube, right. They take derivative of rho 4, I get rho cube. Now, I look for a constant solution which is independent of time, independent of space. So, that will give me a solution rho squared equal to 2 1 by 2 mu squared by 2 lambda. So, that is my D solution. So, what has happened? So, you have to recall our earlier discussion. So, when mu square was negative, I would get paraboloid like this. Well, in fact, rho is a scalar, okay. So, rho will be like this, but when mu becomes positive, then I get this solution which is coming from this solution, fine. But remember, there is a theta field as well. So, this Lagrangian is independent of theta. So, that is symmetry breaking. Okay. Now, after this symmetry breaking, my solution is one of the angles and particular radius. So, my solution is, my psi is square root mu squared by 2 lambda and an angle. So, let us choose angle to be 0. Okay. So, this is the radius and this angle. Okay. So, I am choosing along this direction. Is that clear? So, my symmetry is broken. Okay. So, what? So, earlier how many fields did I have? First we should count how many fields do we have, because it is a complex scalar. So, there are 2 fields, right, 2 massive scalar fields, psi and psi star, agree, and there is an electromagnetic field. So, there are 2 massless photons, right. So, 2 massless photons here and 2 massive fields here, but as a result of this, what has happened of symmetry breaking? Do we have 2 massive fields right now, 2 massive scalar fields? No, because this, well, we will just show you that what is the mass of this field right now along this direction, but this direction along azimuthal direction, along theta direction, the mass is 0. So, we know at least one of them is 0 mass, right. So, one mass is 0, other mass is non-zero. How do I find the other mass? So, as I said, I need to, so basically I need to do a perturbation around this. So, let us do the perturbation. So, rho minus rho naught. So, this is rho naught for me, okay, square root of this rho naught, and the perturbation is chi by root square root 2. I am following this gifted amateur book. So, that is chi by root 2 is the perturbation. If I substitute it there, so actually you can do this algebra, okay. In fact, you do not need to go to the Lagrangian. So, I just substitute rho from here, which is rho equal to rho naught plus chi by root 2, okay. Now, this will be rho cube, so which will be rho naught plus chi by root 2 cube, right, minus 2 lambda mu squared rho naught plus chi by root 2, and this will be d squared chi by root 2. So, what do I get here? I will do the simplest possible thing. So, expand these to leading order in chi. Leading order means drop the higher order like chi squared and chi cube. So, this is minus 2 lambda rho naught cube 3 a squared b, right, a plus b cube is 3 a squared b, 2 lambda 3 6 rho naught chi by root 2 square this, and this will be mu squared rho plus mu squared chi by root 2. So, what happens to this these two together? What is the sum of these two? 0, no, because that is a fixed point. How do I get the fixed point? In fact, you can just substitute here, okay, if you are confused. Just substitute rho naught here, these two cancel, and here what and rho naught square you substitute it from there. So, which is mu squared by 2 lambda. So, 2 lambda cancels. So, so basically I get proportional. So, here there is a root 2, this root 2 is ugly, but so coefficient is here mu squared by 2. There is a minus mu squared by 2, there is plus mu squared by 2, there is a mu squared by 2 chi by 2 plus, right, there is a plus, there is a plus here, there is a plus from here and minus here, yeah. So, we get this. Okay. So, this is my new mass, mu by root 2 is my mass. So, I have two scalar fields now, one is massless, other one is massive, and mass is mu by root 2. Okay. Everybody happy with this? So, this I think this is what I get, there is a algebra problem. Okay. So, instead of 2 root 2 is 2 root 2 chi by root 2. Okay. So, I made some mistakes, is 6 and there is a 6 here. So, there is sorry there is minus 3, there is a minus 3, no, the minus 3 I forgot, minus 3 and plus 1 here, the minus 2. So, so the mass is mu root 2, take m squared chi, okay, mu root 2. So, we got a mass. Now, we have one Goldstone mode which is 0 mass and one is this mass. Now, what happens to the photon? So, right now I have not touched the photon field. So, let us rewrite this Lagrangian. So, here this is this part is sitting there, rho square q square c squared. Now, here I should substitute rho as rho naught plus chi by root 2, okay, but chi is small. To leading order I can write as rho naught square q squared c squared and dot 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 is the higher orders. This is my Lagrangian. So, this is minus mu squared chi squared, this is a new scalar particle, okay, which has mass mu, well mu to root 2 mu, because this halves come here, by this transformation a half has come down, okay, here. Okay. So, this is a new guy which has picked up mass. So, rho naught I substitute now from my formula. So, rho naught is what 6 mu squared by lambda, okay. So, that is what we get here. So, this one I can write as half m squared c squared when m is this, okay. So, the photon which was massless has become massive, okay, and not one, all the 3 components. So, the 2 photons, it turns out that other Goldstone mode, okay, which is supposed to be there is not there anymore. Okay. In particle experiments nobody has seen the Goldstone modes, we now seen Higgs and these 3 charged particles or 3 photons which are massive, not charged, okay, 3 photons which are massive. So, this is half n squared c squared, 3 of them, okay. So, photon has become massive, okay. So, this is called Higgs mechanism, okay. So, what we broke the continuous symmetry. So, we got one massless and one massive, but when the effect. So, basically what is told is that this photon basically eats up that Goldstone mode and becomes massive, okay. That is Coleman supposedly popularization. He says this photon eats up this Goldstone mode and becomes heavy. So, EM field has gained mass by eating the Goldstone mode, okay. So, physical implication. So, we start with 2 massive and particles and 2 massless photons, and what we got is 1 massive scalar particle and 3 massive vector particles, okay. Now, this is for scalar field, which is interesting. I mean, I have given you all the basically details, but for QED of course, you need to do much more work. Not QED, you have to do electroweak. ENM plus weak nuclear. So, Lagrangian is reasonably complicated, and if I work out Higgs mechanism for that, then I get these 3 vector particles are the 3 particles which were discovered, W plus W minus and Z, W plus W minus and Z 0. This is okay. These were discovered in particle accelerators before 2000, but this massive scalar particle. By the way, this particle, so which is the Higgs particle in all this? Mu squared by 2 lambda or 6 lambda. So, that mu squared by lambda with a prefactor, that is the Higgs particle. Okay. So, this scalar particle which was massless, by continuous symmetry breaking it picked up a mass. Well, it was not massless, sorry, I take back. So, it picked up this new mass, it was there was a mu squared is there. So, it is massive, but it picked up this new mass, and there is a Goldstone mode which was 0 mass, but then this photon ate up that Goldstone mode and became fat and massive, and that is what we got these 3 massive vector particles.